So there's a new section on Moodle that I want to talk about today, and it's this section called CI/CD. So there's just a set of slides that I want to work my way through, and hopefully next week we'll have a lab on this topic. I'm saying hopefully because I'm undecided as to what two options as to what I'll do in next week's lab, but that's for me to decide, I guess. So the slides, we'll just talk my way through them. So it's more of a theory lecture today, I guess, than a demo demonstration stuff, but that's okay. So CI/CD is another critical part of this agile approach to software development. And it's CI/CD for short. There's kind of two parts to the CD, as we'll see. But the context again for this, as I guess with everything that we do on this module, is you've got a team of developers working on a project, and quite often that team may be distributed globally, and they're all busily developing code and writing unit tests for their code, and there are integration and end-to-end tests being written as well. And this is all going on, and clearly we need to bring people's code together into one unit, or we need to integrate people's code. And so how do we do that, and when do we do that? We also would like to have one kind of characteristic of the agile approach is we'd like to have a working application as soon as possible. Now, the application obviously won't be fully featured, but the sooner we can get a deployable version of the application that we can deploy onto and hopefully make available to the end user as soon as possible, then that's always a better situation to have, because once a user can get their hands on the application and use it, then you can get feedback from them, and that feedback will inform your subsequent development. So I've never started before with a definition, but I suppose this is what we might call a definition. So I'm going to talk about CI first, and then CD is just an extension of the CI idea. Now, this definition is from a person called Martin Fowler, who would be very highly regarded in the whole software engineering space. So his definition of continuous integration is that it's a software development practice where members of a team integrate their work frequently, and I'm saying their frequently could be daily, but it's a very high frequency anyway. They integrate their work, in other words, their code, both application code and test code, which leads to multiple integrations per day. If you've got every member of the team integrating their work on a daily basis, then you've got multiple integrations per day. Potentially, it doesn't have to be per day, but I want to get the impression across that it's very regular. And each integration is verified by an automated build, which includes test. Now, a build, I guess, if we were developing a Java-based application, a build would consist of compilation of all of the source code and packaging all of that source code, the output of the build into some sort of jar file. In the case of JavaScript, it might be transpiling all of your code into one single bundle, or which would also be a JavaScript file, As you know, if we talk about the web app development module that you're working on, where you're developing a React app and the code is broken up into multiple files, and that code contains JSX, as you know. All of that code, though, the JSX has to be transpiled or converted back into ES6, ES5 JavaScript. That would be part of the build process for a JavaScript React application. And not only does it have to be converted into ES5 JavaScript, but all of the code has to be packaged into one JavaScript file. That's a process we call bundling, which is something I'll talk about later on in this module, although Roseanne might already have covered it briefly with you. So the notion of building depends on the source code that your application is developed on, but it involves some sort of process or step, and that process is automatable, hopefully. So when we talk about build here, we're talking about that's the automation process, and as well we're talking about running our tests in an automated fashion, which we have a good appreciation of from this module. So all of that has to happen, all of that building has to happen every time a team member integrates their code with the rest of the application. And if every team member is integrating their code on a daily basis, then we've got multiple builds, automated builds happening daily, weekly. And the whole point of all of this is at the very end there to detect any kind of errors or bugs in your application as soon as possible. So that's all kind of comes under the heading of continuous integration. Why do we do all of this? Well, the purpose is to try and produce better quality software, which is what the second definition is focusing on. It's all about improving the quality. Quality because, you know, we're identifying bugs or errors as early as possible in the development process, whereas with the waterfall approach, we only would identify bugs at the latter end of the waterfall process. So the how and why then, how do we actually achieve continuous integration? A lot of this we actually have already covered in this module. So number one there, about maintaining a single central source repository. Well, in today's terms, that means GitHub. So everybody would be pushing, every team member would be pushing their code to GitHub. Number two, automated builds, kind of automated build tasks. That's okay. Number three, everyone commits every day, but I've put every day kind of in brackets, just doesn't literally have to be every day, but it has to be very frequent. To the central repository, that's really a git push in GitHub terminology. So we're all very familiar with those aspects, and they're all going to contribute to this continuous integration idea. Now, there is a part of continuous integration that we don't know anything about yet, and that's what the purpose of the next lab accompanying this set of slides will be about. Number four, to do the build on a CI machine. So where do you actually, when we push our code up to GitHub, we want that to trigger a complete build of the application and a complete execution of all of the tests that have been written so far. So on what machine do we actually, or computer, do we carry out that automation? And the CI approach would be to have a separate server that carries out all of that automation. It's not the responsibility of a team member to do it. It's actually just a separate server that takes care of that. And the triggering of the build and the running of the tests on that CI machine, on that separate server, that is automated as well. So it isn't the responsibility of a person to cause the build to happen on the CI machine. It's automated, and we'll see that in the accompanying lab. Number 5, keep the build fast. Well, obviously, because if we're going to be doing this build on a daily basis and perhaps many times in one day, then it needs to be there needs to be a quick turnaround in the whole build automation. And we should avail of caching. By what I'm getting at there in the caching, for example, in relation to a React app, we should cache the node modules. We don't want to have to go installing the node modules every time we do a build. The node modules from the previous build will suffice unless the package.json has been changed. And number 6, test the application. Now, ultimately or eventually, you are going to be deploying your application to a server or some sort of cloud environment, which the end user is going to be able to access. But from a CI point of view, we'd like to have to mimic that production environment, have a copy of it or a clone of it, so that obviously we can't be doing our building and running of our tests, automated tests, on the actual environment that's available to the end user. Clearly, that's not a clever idea. So we need to have as close as possible, a clone or a copy of the environment that the user is accessing, which we call the production environment. The clone we often refer to as a staging environment. So we have a staging environment and a production environment. The production environment is the one that's the end user is accessing. The staging environment is the one that the development team is accessing. Number 7, make it easy for everybody to get the latest executable. That's fine. It's going to be available probably on the staging environment server. And number 8, make the process transparent for everyone. That's all about the how and the why. Then it's about detecting development problems early. I've already mentioned that. Find and remove bugs as early as possible. 1, 2, and 3 are really kind of saying the same thing. And it's always better to remove bugs as early as possible from a cost point of view, from a scheduling point of view, and from a budgeting point of view. Number 4, increase the project visibility. Everybody will be able to see, everybody on the team will be able to see what happened in the last automated build that was carried out on the CI machine. That's obviously very important. It's not the preserve of the team leader. Everybody will be able to access that CI machine and see what the outputs from the last most recent build was, whether it passed or failed, did all the tests pass, etc., etc. Number 5, deliver new features. That's the whole point of this whole CI/CD process, is to get features delivered to the end user as early as possible so that we can get feedback from them. Number 6, improve team cohesion. That's okay. Number 7, have greater availability of deployable software. In number 7, this is one of the aspects of the agile approach. We'd like to have a version of the application, albeit it may be a skeleton, but have a version of the application that we can deploy and make available possibly to the end user, but at least have it in a state that it can be deployed, whether it be to the production environment or to the staging environment, but it is deployable as early as possible. This slide is saying much the same thing, really. It's all about getting better, faster, cheaper code available. So you can read through those things, those points yourself. So that's the CI part. The CD part then of this whole process. So continuous delivery there, we're saying, is a development discipline. Again, it's a development discipline where you build software in such a way that it can be released to the production environment at any time. Now, the emphasis there is that it can be released. It's not automatically released to the production environment. It's a manual decision as to whether we will release the last build of the software that was carried out on the CI machine and it was deployed to the staging environment. Will we actually release that version of the software to the production environment and thus make it available to our end users? So that's what continuous delivery is concerned with. But its objective is to always have a build of the software, an executable of the software available for deployment to the production environment almost on a daily basis, where each build obviously is an improvement on the previous one, whether that improvement be a bug has been fixed or a new feature has been completed. So that's continuous delivery. Then there's this notion of continuous deployment. And the difference between the two is that continuous deployment is where every new successful build of your application that has been deployed to the staging environment, tested on the staging environment, it passed all the tests. If that is the case, then that version of the application is automatically deployed to the production environment. So your end user is getting upgrades to the application, could potentially be daily. Some of those upgrades will be minor upgrades, usually bug fixes. Some of them will be major upgrades, new features added, or existing features enhanced or modified in a way that the user wanted them to be modified. So the difference between continuous delivery and continuous deployment is that the decision to release the most recent build of the application to the production environment, in the case of continuous delivery, that's a decision made by a member of the team leader. They have to, if you like, press a button to actually release it to the production environment. Whereas in continuous deployment, it happens automatically. And in fact, VS Code, which is a tool that we all use every day, if you notice every time you restart the tool, there's a new version of the application, of that actual application available to you for upgrade. And you, the user, can decide whether you want to avail of it or not. You may not have noticed that happening, but that is actually the case. So the VS Code application is being continuously upgraded, and there are new versions of it available to you, possibly on a weekly basis. I'm not too sure how frequent it is. How do we achieve CD? Much the same kind of issues as with CI. So team members must continuously integrate their code into the overall application. We need to run automated tests on a very regular basis. We need to deploy the application to a production-like environment termed a staging environment. So I mentioned that to you. So a staging environment is a server, I guess, really, or a cloud service where you can deploy your application to. It's not available to the end users, it's just available to the team. And that staging environment is as close as possible a clone of the production environment. Why do we do this? Same reasons, really. Better customer experience, quicker feedback from customers, reducing the number of bugs that can get out to the production environment. We want to minimize that. So all of the usual kind of positive reasons as to why we would engage in CI/CD. This is a diagram I found on the web. I probably should have drawn one that's a little bit closer to what we kind of know about software development and testing and all of that. So some of the terminology is slightly misleading. So this is kind of a visual representation of continuous integration, continuous delivery, and continuous deployment. So continuous integration is about build here really is this idea of compiling your code, and then once it's compiled successfully, you run your unit tests. Maybe unit tests mightn't be we might call them end-to-end tests here. Actually, might be closer to what I've been talking to you about. So there's a distinction here between the build and the testing, whereas earlier on I said build kind of includes automated tests, but they're breaking it up here, but so what? Run all your tests, your end-to-end tests, then deploy the application to the staging environment, run your end-to-end tests again, really, against the staging environment, because this now is a very close approximation of the production environment. So that's kind of the continuous integration idea. Continuous delivery is all of those stages, plus this additional one. Sorry, something is in my way here now. Sorry, just give me, oh yeah, okay. Something just popped up in my way. The additional step here is where you're deploying it to the production environment. But I don't know if you can read it or not. The transition from here to here is a manual transition. Somebody has to make the decision, and somebody, if you like, presses the button for this step. In continuous deployment, it's an automatic step in the whole process. And it's really only software houses that have been working on the whole CI/CD process for a number of years. It's only those kind of software houses that would have full continuous deployment. Many software houses would have continuous integration. Some would have continuous delivery, and fewer again would have continuous deployment. The objective, of course, is that you want to try and achieve continuous deployment, but it's by no means straightforward. So you have this continuous integration process in your software, in your software organization, but is it actually successful? Is it useful? Does it work? And the only answer to that would come from measuring it. So it's important to have metrics and to monitor those metrics. And I'm just suggesting here some of the metrics that you might use as a software organization to determine whether your continuous integration process is a successful one or not. One simple measure might be what's the rate of your successful builds? A successful build is a build where all of your tests pass. Now that, does that happen on a very regular basis? If it doesn't, then obviously we need to correct that, because that would be clearly an objective, to try and have every build a successful one. And it may not be successful because we are writing poor tests, or our application code is always buggy. So that would be one simple measure. Another measure might be, now obviously, there are going to be some builds that will fail. And the question is, how quickly do we get to a stage where we resolve the issues and get the build to be successful? Does that take too long? And we obviously want to try and reduce that time span. Total number of, static tool errors. I don't know if you're familiar with linting in the JavaScript world. A linting tool is a tool that will analyze your code, your source code, to identify poor practices in your coding style. So there are tools out there that can do that. In the JavaScript world, they're called linting tool. It's not actually specific to JavaScript. So linters are tools that will just analyze your code and identify not so much errors, but just poor coding practice. We haven't used them, although I think the Create React App tool has them built into them. So these linting tools would be part of the build process. So the linting tool would tend to execute first. It would analyze the source code. And if it didn't find any errors in it, then the code is compiled or transpiled, and then you run your tests. That's kind of the sequence. So if you do have static analysis tools as part of your build process, are those tools always identifying errors? And if they are, that's clearly not a good situation. How good are your unit tests? I haven't talked about line coverage in relation to testing. It's a way of measuring how good your tests are. I may come back to it at a later stage, but there are ways of assessing how good your tests are. And that's what these test coverage metrics are all about. So as a software organization, you should decide on a subset of these metrics and continuously measure your continuous integration process with the objective of improving whatever metrics you're using. Because there's no point in having a continuous integration process if it's only slowing down the development work. Now, the continuous integration platform that we are going to use is called GitLab. It's an open source platform, and you can either run it on your own server or you can run it. It's also available on the cloud if you like, and we will use the cloud version of it. Now, what's GitLab? It's a lot more than just a continuous integration platform. It's really an entire project management platform, but we're only going to use a part of it. And the image I'm showing you here is telling us about all of the different aspects of this GitLab platform. So number one, GitLab actually has an equivalent of GitHub. So it has a Git repository aspect to it. And so we will be pushing our React app to the GitLab repository, and you push it in the exact same way as you would push to GitHub. So that's just the repository. Then this CI part is we'll be using the Git repository. This CI part is the part that we will be using as well. And really, that's about it. We won't be using the other aspects of the GitLab platform. But for example, the user management here, user here really refers to a team member. So GitLab will allow you to set up your team members so that they can use the GitLab platform for a particular project. So maybe certain team members can only have access to the repository. They don't have access to the continuous integration part of a project. This area here, issue tracking, as bugs are identified, whether it be by team members or by customers, those bugs need to be documented, and some team member needs to be assigned to the bug to resolve it. So managing all of that is handled by this part of the tool. The wiki part is where you would use that for all the documentation associated with a project. So maybe the user manual, the API documentation, that kind of stuff. So there are various aspects of this GitLab platform. And as I said, it's more of a full project management platform than just a CI platform. But we are only going to be using the CI part of it, as well as the central repository. So we're only going to be using GitLab CI. And what it is, it's fully integrated with the GitLab repo. So we'll be pushing, essentially we will be pushing our React app to the GitLab repository, and that will automatically trigger a continuous integration process for us. So it'll do a build, run our tests, deploy the application maybe to some cloud platform. That's fine. The why is really kind of the same as before, so we don't need to rehash that. Now, I'm saying the headline here is GitLab CI concepts, but the concepts are actually, there are lots of other CI platforms out there that I could have decided to use. Previously, I was using one called Jenkins with the earlier classes, but I moved away from sorry, not Jenkins, Travis. Travis is another open source cloud-based CI platform, and there are many of them. I've just decided to use GitLab, but all of them have the same kind of concepts. So the concepts from a CI point of view, we talk about pipelines, stages, and jobs, where a pipeline is comprised of many stages and a stage is comprised of many jobs. A job might simply be to install your node modules or create a build version of your React app or run all of the end-to-end tests. They would be typical jobs. But in general, jobs are allocated to stages, and a stage is part of a pipeline. That's the kind of terminology that we talk about. And so I'm saying here, a pipeline is a group of jobs that get executed in a stage. So a stage has many jobs in it, and all of the jobs in a stage are executed in parallel. Okay, all of the jobs in a stage are executed in parallel, and the stages are executed in sequence, in a particular sequence. And if any job within a stage fails, then that pipeline is judged to have failed. And a pipeline is something that we would run regularly. So when I talked earlier on about every time a team member pushes an update to the central repository, the central repository in this case will be the GitLab repository. Every time that happens, what results is an instance of your pipeline is executed. And the pipeline executes the stages within that pipeline, the jobs within each stage, et cetera, et cetera. So that's kind of how things work. Now, in the case of the GitLab platform, how do we actually define or code up our pipeline? And there is a file with a specific name, and it's a YAML file. YAML is just a slightly cleaner version of JSON. So as a software developer, what you've got to do is create this file, place it in your base folder of your project, and inside this file is where you define the pipeline for your particular project. And as we said a few moments ago, that means defining all of the stages that make up your system build and all of the jobs within those stages. Now, in our case, there may be one job per stage, and there may be only 3 or 4 stages. But in more elaborate applications, it would be more complex than that. This is a screenshot from the GitLab website. So GitLab is actually, you're going to need to create an account for yourself on the GitLab platform, but it has a web interface. And this is just a screenshot from that web interface. And what this screenshot shows is, it shows the result of a number of executions of a pipeline that I have created for a particular project. And so we can see the pipeline, what its status was in terms of did it pass or fail. So this one passed, this one passed, this one failed for some reason. The pipeline, each pipeline execution. So this is the same pipeline, but it has been executed many times. And each execution of the pipeline is given an identifier, which is generated by GitLab. So it's just an ID number. Each execution of my pipeline results or is the result of a push to the GitLab repository. And so it's what it's telling me here is the actual commit that triggered the execution of the pipeline. And over here, what we see is, here, we can see that this pipeline had 3 stages in it, and each stage was successful, whereas this one down here, the last stage seems to have failed. The last stage in this case, I think, was the actual running of my tests. This one was the installation of the third-party modules, the installation of the node modules. This one was just building the React app. I think it was for a React app, where the building was, transpiling all of the code and creating a single JS for your entire app. And the third one then is running of my end-to-end tests. But either way, what you're seeing is a number of executions of a pipeline, just in some information on that. Now, so in GitLab, we talk about the runner. So what I'm showing you down here at the bottom maybe might be the best way. So this is Maria representing the sequence that happens on a regular basis. So this is Maria, the user, or the team member. They're developing code on their local machine, and eventually, and they're probably developing tests and running their tests locally. They're happy with their code and they push it to the GitLab central repository. When that happens, automatically, the GitLab CI environment, what it does is it looks to see, is there a file called GitLab CI.yaml? Remember that file I mentioned to you? And if it finds that file, then it knows it needs to run a pipeline. Now, where does it run the pipeline though? Where does it actually execute the pipeline? The GitLab and the GitLab platform have a number of servers distributed globally. So it finds one of the servers that's currently free, and it loads the GitLab runner, which I'm talking about up here, which is just an application. It's written in a language called Go. It loads that GitLab runner onto the available server, and that GitLab runner, it controls the execution of your pipeline. You don't have to really worry about this GitLab runner, but I'm just explaining what happens kind of behind the scenes. The GitLab runner then executes your pipeline, all of the jobs within the stages, and it reports back to the GitLab website. And so it's, when I say it reports back to it, that's what allows the GitLab website to, display this kind of information here. So what you'll be doing in the lab is you'll be creating your YAML file that describes the pipeline that's appropriate for your application, a React application. And you will be pushing your code up to the GitLab repository, and GitLab takes care of the rest. It will take care of triggering the actual execution of your pipeline, reporting back to the GitLab website, and then you can see what was the result of the pipeline execution. And if there are issues, then you fix them. So the runner is an application. I just want to make sure I'm not skipping anything here now. It's an application to run your jobs and send the results back to GitLab. That's fine. The actual GitLab runners are written in a language called Go. Go is a very high performance language because we like our pipelines to execute as quickly as possible. So they'll be running on top of a Go application. So that is beneficial in terms of the execution time. Works with, okay, well, the GitLab runners can be run on any platform, but we don't really worry about that. We'll be probably running ours on a Linux platform. And GitLab uses Docker containers an awful lot. I'm not sure if you're familiar with Docker containers or not. You don't really have to be, but it's part of the whole GitLab environment. So this YAML file that I'm talking about, it's going to be just part of your source code, and we need to locate it in the base folder. So there I have a GitLab ci.yaml file, and this is kind of an insight as to what it looks like. It's I don't know if you've come across YAML before, but as I said, it's you can interpret it as a cleaner form of JSON. And what this excerpt from a YAML file is telling me is that this particular pipeline has 3 stages to it, I've decided. The stages can be called anything. It's completely arbitrary, but these are meaningful names, I think. This line here, what actually happens in the, so in the previous slide, I talked about this GitLab runner, which runs your pipeline, but you probably want to run your, if it's a JavaScript project, you will want to run your pipeline in a node environment. So what this line here is actually telling the GitLab runner is to find a particular version of the node platform and use that as the base platform for running your pipeline. Technically, what this is here is a reference to a Docker container image. A Docker container image can run on top of a virtual machine environment, and a virtual machine environment runs on top of the operating system. So the stack is kind of, you have your operating system on your server, on your GitLab server. On top of the operating system, there will be a virtual machine. On the virtual machine will be your GitLab runner, and the GitLab runner will run a particular container image. And that image is then the platform on which your pipeline executes. So for our React app, as I said, we'd like a node platform to run our different stages. Here's a look at one of the stages. Here's a look at one of the stages, and lo and behold, it's running an npm command. In this case, it says the npm install to run my third-party node modules. Here's another job. This is a job, sorry, within the stage. Here's another job, and it looks like it's running my Cypress tests. But also I'm starting up the Create React App server to run the actual, the React application, if you like. And you'll see this happening in the labs. So these are jobs, and these are stages, and this is an entire pipeline. That's how it looks. And for each job there, you need to indicate, you need to give the job a name. Again, it's completely arbitrary. You need to indicate what stage the job belongs to. So it looks like this job belongs to the install stage, and that corresponds to one of my stages up here. Script is what you actually want to execute within this job. And that's typically something that you might ordinarily type from the command line. Similarly, over here, I've decided to call one of my jobs E2E tests. It's linked to the test stage. That matches up with that. And you can have multiple jobs within a stage. Okay. And what scripts do I want to run? Well, sorry, this is saying what script I want to run for this job. The before script, as it's probably clear what it means, what that is saying is I want to run this particular command before you run this command. And that makes sense. I want to start my create React app server. This means run it in the background. Start my create React app server and then run my tests. So in a job, then you have all of these different properties of a job. Many of them we won't worry about, but so you can define variables that would be kind of environment variables. There's no example of that on the previous slide, but you can define environment variables that are only visible or accessible by that particular job. You can have before scripts, which we saw an example of. Every job will have a script section. There may be a script that you want to execute after the main script. Artifacts are interesting. Sometimes a job produces some output. So for example, if I go back, even though it's not indicated here now, clearly this job will generate the node modules folder within my project, which is running on my CI machine. But those node modules folder need to be available to this job. Now, at the moment, the way I've written this job here, the node modules folder will not be available to this one. I would need to add on the artifacts attribute to this job definition. And that's what I'm mentioning here about artifacts. And you will be doing that in the lab. And then there are other ways you can kind of control the job. You can indicate maybe that the job should only execute when the team member pushes to a particular branch on your GitLab repository. So branches come into play here again. Right, so a lot of talk, as I said at the beginning, and it's not really until you put these things into practice that hopefully they start making a little bit more sense. And we'll either do that in next week's lab or the first lab after the reading week. I'm not going to talk through this set of slides now, so it's kind of saying the same, making the same points that I've already made earlier on. Okay, so that's it for this morning. And unless there are questions, which there never are, but that's all right. So I'm just going to leave it at that for today, and I'll talk to you next week.